Hi students, all of you welcome. Welcome to Sunil Engineering Academy. Students, in this Transformers through topic wise MCQ series, we have completed 8 sessions. It is the ninth one. If you want previous, you can watch in this YouTube channel. Just to start the session, all these questions already completed. If you want, you can click on the playlist and also click on the description box. You can find out the Telegram group. Join in that. You will get a very good content. So all this completed now. Regulation also completed. Think today testing open circuit short circuit test questions. Regulation questions completed. Yes, coming to the first question. Open circuit test in a transformer is used to determine dash constant losses, copper losses, hysteresis loss, eddy current losses. So this open circuit test in a transformer is used to determine shunt branch parameters, that is R naught, X naught, and iron losses. These are also called as core losses, and it is also used to separate iron losses into hysteresis and eddy current losses. Okay, it is generally operated in rated flux condition. Okay, how you can get rated flux? If you provide a rated voltage and rated frequency, then you will get the rated flux. So if you operate or if you provide the supply to get the rated flux, then we can find out all these parameters. Okay, so that is iron losses or core losses. So answer is option A. Answer is option. Okay, this open circuit test is generally conducted like by opening HV open and test performed on LV side. Test performed on LV side. Why? Because the voltage of, requirement is less, meter requirement is less. Okay, that is less range watt meters are enough, and low power factor meter is used. And we can get if the test is performed on LV side, low voltage means current is more, then I naught is sufficient to measure. Sufficient to measure. So we have the availability of meters to measure this I naught. Okay. So here answer is option A. Coming to the next one. Open circuitation in transformer is performed with a dash. Just now I have given a open circuit rated flux. If you want to get rated flux, you have to use rated voltage and rated frequency. So rated voltage and rated flux condition. Coming to the next one, the efficiency of two identical transformer under load conditions can be determined by dash. Can be determined by dash. Efficiency we can directly determine by back-to-back test or Hopkinson test. Okay, so both losses we can get. So back-to-back test is used. Open circuit test and transformer, which winding is generally open circuited? I have already given HV is open, test performed on LV. Test performed on LV side. So open circuit is nothing but HV winding. Coming to the next one. Open circuitation transformer is usually performed by exciting low voltage winding, that is LV winding. We are giving the supply to the LV winding because of dash. If the LV winding is there, then current will be higher. Let us take for example 100 amps. Okay, for example 100 amps. Then what is the I naught? I naught is nothing but nearly 5 to 6%. So let us take 5% means 5 amps. 5 amps meters are easily available. easily available. In the same way, if the test performed on HV side, then for example, the HV high voltage means current is less. Current is less means 10 amps. Then I naught is nothing but 5%. That is in 100, 5% is means 0.5 amps. So 0.5 amps range means we have to use 0 to 1 amp. 0 to 1 amp, that is less availability. So if you want to get this 0 to 1 amps, these are less available and costly also. For example, here if you want to buy 0 to 150 kg weighing machine, just 300 to 400 rupees you can get. In the same way, if you want to measure 0 to 100 grams or 0 to 20 or 50 grams, for this type of weighing machine, you have to pay very high amount. If you want, you can ask the any weighing machine dealers. These are generally used in case of weighing the gold. Okay, so the gold weighing machines are costly than this normal. Okay, so in the same way, here also the meters may be less available, so more costly. So these are easily available and we can get exact measurement. So it draws can sufficient no load current. It can be conveniently measured. Okay, it can be conveniently measured. That is the main reason. And the reasons are nothing but voltage requirement is less, low range watt meters are enough, all those. Okay. The open circuitation transformer, which type of watt meter is used? Open type, low power factor meter. Why? Because in case of open circuit test, no load test case, I naught lags 75 degrees by voltage V. So power factor is less. So low power factor meter is used. Okay. HPF in case of short circuit test. The open circuitation transformer conduct and rated voltage but less than the rated frequency, then what will happen? Which of the following is correct? Okay. Which of the following is correct? Here, whenever the open circuit test has to be performed with rated flux, if you want to get rated flux, you have to operate rated voltage and rated frequency. This is nothing but Vmax is proportional to V by F ratio. Okay. So if the frequency, conducted at rated voltage but less than the rated frequency, as frequency less, Bmax requirement is more, Bmax increases, correct. As Bmax increases, magnetizing current requirement is increases. Okay. As the I mu is more, then what will happen to the power factor? It is decreases. Power factor is always inversely proportional with I mu. So as I mu increases, power factor decreases, correct. Iron losses increases. As frequency decreases, what will happen to the iron losses here? Here, whenever the frequency is less, then magnetizing current requirement is more. Whenever the magnetizing current requirement is more, then iron losses also will be more. So we can say all of the above are correct. All of the above are correct. Okay. So here V by F is not constant. V by F is not constant means WH is inversely proportional to frequency. As frequency decreases, VH will be increased. So iron losses will be also increased. Coming to the next question. The short circuit test. Short circuit test. Here, closed test. That means you can say short circuit. Current. Current is the main consideration here. Okay. So here we have to get the rated current. Rated current. So this test performs always at the rated current condition. It is generally used to determine series branch parameters and also copper losses. Copper losses are nothing but you can say variable losses. So these are used to determine the variable. Coming to the next one. Short circuitation in transformer is performed with dash rated current, rated load current. Okay. Short circuit test and transformer generally conducted on dash side. So already we have discussed open circuit test, HV open test to perform on LV. Okay, short circuit test, reverse. LV is open, sorry, LV is short, LV is short, test to perform on HV. Okay, here conducted on which side they are asking. So test to perform on HV side. So the answer is option. Again the same question, but here they are combining both. So in case of open circuit, HV is open. Open circuit, HV open. Two options are correct. Short circuit test, LV is shorted. LV is shorted, not HV shorted. So the answer is option B. Okay. So we have already discussed this. Short circuit test on transformer is also known as impedance test. Is also known as impedance. In short circuit test, 5% rated voltage to produce the rated short circuit current. Then what is the percentage Z? Z is nothing but voltage by current ratio. Voltage by current ratio. In simple manner, voltage by current ratio. Now, here you want to get short circuit test always has to be operated rated rated current condition. So we have to get 100% rated current, and the voltage applied is 5%. 5%. Yeah, 100% means we have to take as 1. Take as 1. So 5% voltage is enough to produce the rated short circuit current, means percentage Z is nothing but 5% voltage. If that is for example, in the same question, if they have given 5% rated voltage to produce half of rated current, in this case percentage Z is nothing but 5% rated voltage is required to produce how much current? Half of the rated current, that is 10% you will get. Okay, 10% voltage is enough. So the answer is option B. Coming to the next question, 5% rated voltage to produce half of the rated current. What is the percentage? Just now I have given 5% by rated current. Half of the rated current means 10%. If they are asking 1 by 4th, then 5% by 1 by 4th, that is 20%. Okay, so like that we have to give the answer. In order to minimize the inrush current in a single phase transformer, the supply should be closed at the instant when dash. Closed at the instant when dash. Whenever the supply voltage is maximum, in that case we can minimize the inrush current. Okay. Which of the following loss in a transformer is zero even at full load? Which losses are zero? Mechanical losses. Why? Because there are no rotational elements. That is, friction losses will be less. Always zero. Always zero. Okay. And the next two questions we will discuss in the next session. Okay. Okay, students. If you have not subscribed this channel, please click on subscribe button and also encourage me with your likes, comments and shares. Okay, thank you so much guys. All of you take care. Bye guys.